That's it. Okay. So ultrasound, we have covered enough of that. Only we'll pass on to application part. Okay. So uses of ultrasound in food processing. Are you able to see the slide?
Yes, ma'am.
You put it in the document reference which is in untrusted location. Enable external content. Blocked. Okay. So it is mainly used. I told you that low frequency, low power and high power, two types of ultrasound are there, and low power is mainly used for what non-invasive analysis in and quality assessment. You know that is it is used to locate a foreign body in food substances. For example, if you want to locate a microorganism in a food substance, you can identify that is a foreign body, or else any metallic substances which is present in the food substances, or other material which is unwanted substances in food substances can be easily identified by means of this type of ultrasound techniques. Okay, so it is so what I'm talking is about non-invasive analysis or non-destructive analysis of food quality testing. We are using ultrasound. Okay, one is location of foreign bodies, and second one is the analysis of droplet size in emulsion of edible fat and oil. Okay, so it is so in the case of after preparing the emulsion, you need to study about the particle size. Okay, so to study the particle size of the emulsion, that is the fat as well as also oil particle size, to determination of the pattern size of the oil droplets, will be going for ultrasound treatment. Because what we'll do is before that, before analyzing the particle size, you'll keep the material in the ultrasonic bath. Okay, so in the ultrasonic bath, it will what homogenization techniques, and then droplets are converted into smaller droplets, and after this you can go for analysis of the particle size of the particular fat or oil, whatever emulsion substances. Okay, that's the only thing. And the next one is determination of the extent of crystallization. So you can analyze how much is the crystallization extent, how much the crystals have been formed. So this is also been possible by means of what droplet size. Identifying the droplet size, you could be in a position to determine the crystallization of the process. Okay, so if the crystals are fully formed or it is in the growing state, everything can be identified by using this technique. Okay, and the next one is degree of creaming. Okay, the movement of the solid particles or fat droplets to the surface. So when you're preparing any what emulsion surfaces or whatever it may be, or when you're preparing some cream, yeah, that is also cream is also an emulsion. Okay, so how much creaming has been taking place in this case, that can also be identified by non-invasive analysis of the ultrasound. Okay, so these are all the non-invasive analysis, and next comes the high power emulsification process. Okay, so in the case of high power cell disruption, emulsion formation, and quality analysis, all those things are possible by means of this high power ultrasound. So emulsification is the first thing in this case. And the emulsion generated with ultrasound are often more stable emulsion. The emulsion which we get in the case of ultrasound are considered to be the more stable one, and they require less surfactant. Yesterday itself I told you that for the formation of emulsions, you need what actually two phases. You'll be taking two immiscible phases. With this, you'll be adding a surfactant. This surfactant will act as a agent that will keep the formed emulsion under stable condition. Okay, without this surfactants, what happens, the material will be what, the scattering or the separation of the material may take place after forming emulsion. In order to keep them in stability, you'll be what, before that itself you'll be adding some surfactants. When you are going for this ultrasound treatment, there is no need of surfactants, or you can go for the lesser usage of surfactant. Surfactants naturally what we'll use is we'll use go for twin 20, twin 80. All these are all called as what, surfactants, which is used to keep the emulsions under stable conditions. Okay, and not only that, it is also used for in situ cleaning in conjunction with the chemical treatment. So you can go for chemical treatment. That is in the case of what, water bath system, you have what actually soap solution or some solution can be kept, and that will clean the system In addition to the chemical reaction which is kept in the vial the chemical reaction also takes place for the substance or medium which in the vial. At the same time, the ultrasound bath are able to clean themselves also. So that is also possible. The reaction will be carrying out on one phase, one side, and the other side the bath will be cleaning itself. Okay, so that is in situ cleaning is conjunction with the chemical treatment also possible in this case. And the next one is modification and control of crystallization process. You can modify and control the crystallization process. So if I want to produce a crystal size of about what yeah, in terms of micron size or in terms of what millimeter size, you can control the process. That is also possible. And this is also used for degassing of liquids. How will you degas the liquids? When you put some liquid substances, and if you want to remove air, you have to keep on stirring them. When you're going for high rate of when you supply ultrasound at very high frequency, the degassing of the substances takes place, and enzymes can also be inactivated. How enzyme inactivation takes place? Because of ultrasound, what happens? Very high temperature and pressure is produced. This temperature is able to inactivate the enzyme, and also the yeah, temperature as well as also the pressure. That pressure also inactivates the enzyme to some extent in this case. And apart from this, you can also carry out drying process, filtration, and the induction of the oxidation reaction can also be possible with the help of ultrasound. Okay, and this also improves the extraction of organic compounds contained within the body of plant and seeds. That means in the case of seeds, you'll be able to remove oil from this, and in the case of plants, bioactive substances can be removed with the help of this. For example, extraction of anthocyanins, extraction of luteins, that is antioxidant materials or bioactive substances which is present in the plant as well as also seeds can be removed when you are going for ultrasound treatment. And this is also considered to be an effective method in assisting food freezing. That means what? It accelerates the ice nucleation process. You know that in freezing, you might have studied about there are different stages are there. First, sublimation will take place. After that, what happens? Super cooling, and then sublimation, then ice crystallization. Like the process proceeds in the case of freezing of any substances. Okay, and this ultrasound treatment is used to accelerate the ice nucleation formation. Nucleation is the first step. The first nuclei or will join. So the nucleus, what that means? What you if you are keeping liquid substances in the freezer zone, what happens? Actually, the liquid may be a juice. Okay. So in this case, what happens? You have homogeneous substances and heterogeneous substances. Juice is a heterogeneous substance. So when you want to freeze the juice, what happens? It has water. The water is a homogeneous medium, and the juice which contains other soluble solids are there inside. That is a heterogeneous medium. So in this case of freezing, what happens? First nucleation among the material takes place. Okay. So first solvent, water will first what undergo nucleation process. Then afterwards the solute will undergo. Finally, what happens? The entire process takes place. So for that initiation of the freezing process, initiation of formation of the ice crystals, what is necessary? You need to nucleation is the first step that is initiated fast in the case of ultrasound processing. So these two I told you with relevant to this only I have explained the previous cases. Okay, this antimicrobial effect also I have explained already. The antimicrobial effect of ultrasound is largely due to what? Localized heating. One is because due to the generation of the cavitation and implosion process, large amount of heat is released by many of the bubbles. If many bubbles explode at the same time, what happens? That is fracture takes place. Fracture or tearing of the bubble takes place. What happens? All together it creates a very high temperature in this case. Okay, the temperature around 5000 to 5500 degrees Celsius also created during this process, and this temperature rise, that is localized heating we are calling. This localized heating induces the thermal inactivation of the microorganism. And not only that, sometimes what happens, the other one is called as high pressure is released during this process. So that pressure also what it helps in the formation of the free radical, and that free radicals has it damages the DNA of the microorganism. And not only that, apart from the localized heating, DNA damage, there is also possibility for the micro streaming of the cell inclusions out of the cell, so that thinning of the cell membrane takes place. That is, thinning of the cells takes place. Once the cell membrane and cell inclusions comes out, what happens? Cell lysis takes place. So there are three possibilities are there in this case. One is called as localized heating, DNA damage, and then release of the cell inclusions. All these together leads to the cell death or cell lysis is caused because of this process. And effectiveness of the ultrasonic treatment is by means of what? When you are combined with other treatments. So only a single technology cannot be a efficient technology. So what you have to do? You have to go for combination of technology in this case. So in the case of ultrasound also, you have to go for combination of ultrasound with other treatments. So ultrasound plus thermal process, ultrasound plus pressure treatment, ultrasound plus heat and pressure. So this is all the process which is termed as what? Thermosonication. Heat treatment plus ultrasound, and then manosonication. That means pressure and ultrasound. The third one is combined heat and pressure is called as what? Thermomanosonication. In this case, heat, pressure, and ultrasound you are combining together to bring the effectiveness. That means killing the microorganism. Okay, so for this, what you have to do? Usually, not only in ultrasound, in all of the techniques, you have to go for combination of technique. Even in the case of what? Pasteurization, what you are doing? You are killing the microorganism, and after killing, you are not going to keep the substance outside. You are going to keep them inside the what? Refrigerated condition. Otherwise, there is a possibility for the microorganism to grow in this. So you have to go for combination treatment only in all the cases of food processing. Okay, even in sterilization, what you are doing? You are sterilizing the milk, but what you are using? You are using the packaging material. You are choosing a package that would prevent the microorganism growth in these cases. That is also a combination technology. So treatment plus packaging technology are combining in this case. So like this, what happens? This always you have to go for combination of techniques in order to have effectiveness against the microorganisms. This I told you already. And next one is what? Here they have explained ultrasound combined with the heat and pressure. That is called as what? Thermomonosonication or manothermosonication process, MTS process. So in this case, what you are going to do? We are going to combine what? Either pressure, ultrasound is being combined with either pressure, temperature, or pressure and temperature, and the length of the ultrasound treatment can be reduced substantially. So what you can do in this case, when you are combining thermal treatment and also the pressure treatment, you can what? Reduce the duration of the ultrasound treatment in this case. Okay, so simply if you are combining the ultrasound with mild heat treatment, it is found to increase the rate of the microbial inactivation in many of the microorganisms. Okay, then what is the limitation behind the combined ultrasound and thermal processing? So what happens when you are going for ultrasound? That is thermosonication process they are talking about. The thermosonication process, the effectiveness decreases when the temperature increases. Okay, so how this is possible? As increase in vapor pressure and the decrease in the liquid surface tension reduces the cavitation effect. When you are increasing the temperature of the process, what happens? Actually, already there is a temperature effect in the ultrasound. Further, when you are increasing the temperature, what happens? The vapor pressure increases inside the cavity, and as a result, what happens? The surface tension of the liquid medium or the medium which you are going to treat, that will reduce the cavitation effect. Okay, so that is the main thing. So the cavitation effect will be reduced when you are going to combine what? The thermal treatment with the ultrasound. That is the limitation in the case of the ultrasound treatment. And by pressurizing the material, the cavitation can occur at high temperature, increasing the efficiency of the microbial inactivation. Pressure and ultrasound, it helps in inactivation, and pressure and thermal treatment, sorry, the ultrasound and thermal treatment, it reduces the efficiency when you are increasing the temperature beyond certain level. So even at temperatures well below the boiling point, yes.
Ma'am,
Yeah.
slides are not changed.
Oh, sorry. Are you able to see now?
Yes,
So
ma'am.
this is what I explained so far, and this one you have already taught you this one, and this one. Please. When I go for slideshow, it's not showing. Okay, sorry. Would have informed me already, no. So sometimes when you are reducing the temperature well below the boiling point of the medium, the pressure during the ultrasound treatment will affect the microbial destruction. So you should not go for low temperature and you should not go for high temperature also. You have to choose an optimal temperature for the destruction of the microorganisms. So when different bacteria were treated by ultrasound, increasing the pressure from 0 to 400 pascals produced a substantial difference in the D value, substantial decrease in the D value for the Streptococcus phaseum, Listeria monocytogenes, and then Salmonella enteritis and Aromonas hydrophilia. Okay, hydrophila. So these are all the cases where when the pressure is being increased from 400 kilopascals, 0 to 400 kilopascals, the D value decreases in this case. Actually, when there is a decrease in D value, the process is going to take place very short. That is a meaning. So pressure combination with ultrasound, it increases the efficacy of the treatment. That's the thing. So combining pressure and thermal treatment further increases the antimicrobial effect. So what you are going to do now, first you have seen pressure separately, thermal separately, then pressure, thermal and ultrasound it has increased antimicrobial effect. A combined pressure, thermal and ultrasound treatment of Salmonella enteritis yeah, Salmonella entities will give D values that were lower than a combined thermal and ultrasound treatment at the same temperature. That means what they are telling, the D value further decreases when you are going for combination of pressure, thermal and ultrasound. That's the thing. Okay, when compared to the thermal and ultrasound treatment, you will be able to obtain a D value of less than that of the thermal and ultrasound. Okay, so that is another one. The D value, what is D value? D value is nothing but anyone of you, can you please explain what is D value? What is D value? Have you studied in your lower classes or not? Yes or no, please?
A thermal death time, ma'am.
Yes, thermal death time. What is thermal death time?
The time at which the microbial destruction is happened, ma'am.
Microbial destruction takes place.
The complete
So,
destruction of microbes.
yes, okay, you are
The temperature
partially,
and time.
yes, it is partially correct. That means what is meant by thermal death time or D value? D value is nothing but what it is the temperature required to kill the microorganism at a particular time. That means what temperature requirement. What 90% of the population of the microorganisms will be killed in this case. That is called as what D value. There is nothing but what the temperature at which 90% or 1 log reduction in population is possible is called as what D value. Okay, so that is nothing but thermal death time of the microorganisms. So that's it. Okay, so the D value decreases in the case when you're going for combination of pressure, thermal and ultrasound when compared to the thermal and ultrasound alone. Okay, the sensitivity of the bacterial spores can also be increased by combined pressure, thermal and ultrasound. That means what? The sensitivity means what? The microorganisms are susceptible more for what? Pressure, thermal and ultrasound treatment. You can kill them very in a shorter period of time. That's the thing. Okay. The next one is decontamination of food substances, food surfaces. Ultrasound treatment was able to be effective at reducing concentration of Salmonella typhimurium on chicken breast skin. That means what? So surface. So you know that in the case of meat, fish, and also in chicken, the microorganisms, large amount of microorganisms are present on the upper surface and the inner layer remains sterile. Okay, so that means what? It is not, microorganism cannot penetrate to the inner layer, they will be found mostly on the outer surface. So that's why what the surface decontamination is mostly sufficient in case of the food substances. Okay, so in the case of this so hence this ultrasound treatment is effective in reducing the concentration of the salmonella which is found on the surface of the chicken breast skin. Okay, and decontamination treatment in a chlorine solution reduced salmonella typhimurium contamination by 0.2 to 0.9 logs, while ultrasound treatment we can reduce the population of the microorganism to 1.1 log reduction in population can be achieved by means of what? Ultrasound when compared to that of the other treatments, chemical treatments. Okay, and a combination of 0.5% chlorine and ultrasound treatment were the most effective in reducing the salmonella typhimurium, and the log reduction achieved in this case is 2.4 to 3.9 log reduction. That means what they are doing before they are treating this with ultrasound, and they are going for chemical dipping also. They are dipping the chicken breast skin in 0.5 chlorine solution, and afterwards they are going for ultrasound treatment. So by means of this combination technique, you will be able to reduce 2.4 to 3.9 logs, 9 logs of population can be killed in this case. That means what? 10 power 2.4, 10 power 3.9 population can be killed in this case. Then decontamination of processing surface. So processing surfaces, you know that steel trays, steel baskets, steel shackles, knives, whatever it may be, you can take. So in a practical investigation in a commercial chicken processing plant, ultrasound assisted cleaning of what? Plastic trays, steel baskets, and then steel shackles was effective at reducing the microbial and other contaminations. Okay, so for that also you can use. So surface decontamination is possible, and utensils also can be cleaned with this, and this also enhances the mass transfer also in this case. So enhancement of mass transfer, ultrasound has been shown to improve the efficiency of many mass transfer processes, either through a direct involvement in the process like cavitation or microstreaming or aquastreaming causing agitation to improve the mass transfer process, or cavitation, or else it will create cavities in the material, thereby mass transfer is enabled in this case. Or they support other process like what? Agitation or microjet formation to assist the cleaning formation is also possible. So this ultrasound treatment what is shown to improve the efficiency of the mass transfer process. How the efficiency is being improved? By means of direct involvement in the process. How it's been directly involved? By forming cavity, okay, or else the microstreaming of the material which is present inside it, inside the microorganism. Cell inclusions will be what? Released, okay, or acoustic streaming. That means what? The ultrasound causes agitation of the material, that creates what? Mass transfer. So cavitation creating, and not only that, cavitation also what it is? Cavitation is nothing but what? Tearing or the fracture, that creates pores, and that leads to what? The inclusions to come out of the materials. Okay, or also it's also support other process like what? Agitation or microjet formation to assist the cleaning process also possible in this case. Then enhance, it also enhances the mass transfer process, and not only it also helps in the yeah, heat transfer process also. Sound and ultrasound can be used to enhance the rate of heat transfer process during freezing operation, thawing operation, and cooking operation. And before that, I also told you that it is also used for dehydration process, drying process. We are using ultrasound. Okay, so it is used to increase the heat transfer rate also. In case of thawing and cooking, ultrasound assists the process of increasing the rate of the heat transfer with our surrounding medium and by absorption of sonic energy by the material. How it increases the rate? Because the sonic energy is being absorbed. The sonic energy is nothing but what? It is mechanical energy. Mechanical sound waves are absorbed by the material and surrounding medium. They'll absorb it, and from the surrounding medium, once it is being absorbed, from this what happens? The heat will be what? Heat transfer from the substances takes place. It supplies heat, and then what? The whatever may be the material which is present inside the medium will come out, drying, thawing, or whatever may takes place in this case. By contrast, in samples being frozen, the absorption of energy from the sound waves, which reduces the cooling rate. So in the case of what? Thawing frozen process, when the substances absorbs energy, what happens? Heat releases. It releases heat. So when it releases heat, what happens? The cooling process will be what? Delayed in this case. Okay. So the cooling rate will be delayed. In the case when when the energy is being absorbed, heat transfer, removal of heat may takes place at a faster rate. Okay, it cooks the material, so heat is being removed. Cooking takes place or thawing takes place very fast. But in the case of if you want to freeze the substances, what happens? Once the energy being absorbed by the substances, the energy, what happens to the energy? The energy once again heats the substances, and you need furthermore cooling effect to remove that heat also. So the cooling rate is delayed in this case. Okay, So it needs to be balanced against the improved heat transfer coefficient and also improved product quality produced by increasing the ice crystal formation, nucleation. So it requires extra effect in this process when you are going for freezing process using ultrasound. So next one is processing of protein foods, and ultrasound can be used to enhance the processing of material containing proteins. Okay, so what such as what tenderization of meat. So meat tenderization is the vast area which found application in the case of what ultrasound. Okay, so it is also used in the destruction of microorganism which is present in the meat substances, then homogenization of the substances, protein extraction from the cells, and also enhancement of membrane filtration. All these things are possible by using ultrasound treatment. The ultrasound mechanisms can enhance the process such as what localized or bulk heating, I told you already, and the microjet formation and high shearing action will be more in this case. Liquid agitation is possible, and polymer chain lysis, that means what the case of the what microorganism, the peptidoglycan layer that breaks in this case leads to cell lysis, and free radical formation takes place when the pressure, when you are applying more pressure at this stage. What happens, the free radicals are formed, that free radical damages the DNA, can also denature the protein present. Okay, so the heating, microjet formation, high shear taking place during this process, and all these are together, they will denature the protein during the ultrasound treatment process. Okay, so that's why we are telling this is enzyme inactivation is possible with the help of ultrasound. Okay, so ultrasound as a processing aid. So how it is going to helps in processing, how it going to helps processing of food commodities. Ultrasound has been used to enhance the efficiency of the food related enzymatic process, including enhancing the esterification of glucose. So yes, formation of esters, that helps in the ultrasound helps in the formation of esters, and hydrolysis of olive oil, and also proteolysis of casein by chymotrypsin are possible in this case. Proteolysis means what, denature of protein in this case of what casein. Okay, by using chymotrypsin enzyme. Okay, that is possible. And the olive oil can be hydrolyzed by using this. Glucose can be esterified by using ultrasound treatment. So in all the cases, ultrasound play a major role. It helps in enhancing the process. Okay, ultrasound increases the rate of the invertase catalyzed hydrolysis of sucrose. So that means what, in sucrose hydrolysis, ultrasound play a major role. And then alpha amylase and glucoamylase hydrolysis of starch and alpha amylase hydrolysis of glycogen are also possible by using ultrasound. So what is meant by alpha amylase and glucoamylase hydrolysis of starch? So starch is a complex substance. You know that it is a polysaccharide that as such cannot be used. So in many of the cases, and this found many application in the case of what starch hydrolysis in corn milling industry, you'll find this application. Hydrolysis of starch. We need to what hydrolyze the starch in order to convert them into valuable products like what high fructose corn syrup. Okay, that is an industrially important process. So in order to convert the starch into industrially important product, you have to go for what two treatments. One is known as liquefaction process, and another one is called as saccharification process. Liquefaction is nothing but what, conversion of the large starch molecule into smaller fragments like dextrins. So by using the enzyme called alpha amylase, so that is liquefaction, breaking down the starch molecule into certain length. That is by using alpha amylase liquefaction process. That is hydrolysis process. And later on, what happens? Glucoamylase is the enzyme which is used to hydrolyze further the dextrin molecules into what, individual glucose molecules. That is called as what, further hydrolysis called saccharification. Saccharides are formed, sugars are formed. So these are all the two enzymes. Alpha amylase and glucoamylase are the enzyme which is used to hydrolyze the starch into individual glucose monomers. Okay, for this purpose we can use. And not only that, this alpha amylase hydrolyzes the glycogen also. What is glycogen? Glycogen is nothing but a carbohydrate reserve which is stored in our body. When you consume excess amount of carbohydrates, that will be stored as fat in the body in the form of glycogen. Okay, so that is this glycogen reserve only will help us when you are starving or when you are not getting sufficient amount of food for your body metabolism, the glycogen reserve itself will help in the fat metabolism, and this is fat metabolism actually. This will provide enough amount of carbohydrates which is needed for our body. So this is also useful for the hydrolysis of glycogen is also possible with the help of the alpha amylase. That is these two statements tells about how ultrasound is used as a processing aid. Okay, I told you that meat tenderization is a vast area where we are using ultrasound treatment, and in the case of horse meat, we are using what? Yeah, tenderization frequency is 22 kilohertz. We are using, and power input is 15,000 watt, 1500 watts, and that is they have given. Ultrasound treated meat have lower shear force and than the conventionally processed one. And then chicken, they are using 40 kilohertz and 2400 watts, and time is 15 minutes. Beef, and then what? The other one is lamb. All those things they are using what? Ultrasound treatment. Okay. So this is uh, the use of ultrasound in food applications. Any doubt in this? Yes, please.
No, ma'am.
No, no,
No,
ma'am.
ma'am.
So we have completed ultrasound, and we have to switch over to high pressure processing. Next class we'll see. I want to leave it. So I already it is 9:40. When I teach it will take another 10 to 15 minutes. You have a class after this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. Whose class you have? Gopi sir?
Ranganathan.
Ranganathan sir. What sir is handling for you all? What subject?
Material science.
Food material science. Oh my God.